Hello. Quarantine. Snacks. Wonder what type of new snacks you guys have come across. Because for me, I have found a newfound, older appreciation of the spectacular breakfast food. Now it's called breakfast, but we can use that term lightly because it's great for breakfast and lunch and dinner and snacks of any time. And I forgot how awesome the cereal is, except for when you eat it, the roof of your mouth gets really scratchy and whatever. But still, newfound appreciation, Captain Crunch. Because I really need to lay off the chocolate chip cookies. I've been eating too many of them. I've been making too many of them. And I'm going to be one of those people that comes out of quarantine a little bit heavier than I went in. So I need to stop that. I need to find a better snack. Celery. That kind of good stuff. All right, guys, here we go. 10.7, operations in scientific notation. We're going to do this in 2 days. Today is just going to be operations with addition and subtraction with numbers in scientific notation, and tomorrow it's going to be multiplication and division. And I really, really hope you guys watch this video before you try doing your homework, because I have a helping hand that helps you out. Try to remember how to do this. I do not follow the book, so please make sure you watch this before doing your homework, because it'll be a whole lot less confusing. It's a little bit chilly out today, so I decided to keep my onesie on. I got Harry Potter and my Hufflepuff hat. Gotta still represent even though I'm in quarantine. One example today, but I'm going to do quite a few problems just so you guys get the drift of this. All right? Here we go. 10.7, operations with scientific notation, addition and subtraction. Example 1. Find the sum difference. And then write answers. And sign on. Here we go. And I have this little helping hand guy. You're going to get introduced to him shortly. That's going to help you, like a little helper hand, to help you remember what to do on some of these problems. I said I'll remember a whole lot in there. Here we go. 4.6 times 10 to the third plus the quantity 8.72 times 10 to the third. Those are both threes. Just example 1. All right, now before you can do any problems in scientific notation when you're either adding, subtracting, multiplying, or dividing, you first have to make sure that your powers are the same. Pardon me, you have to make sure the powers are the same for addition and subtraction today. You don't have to worry about it for tomorrow. Sorry about that. My brain's still getting going. So you have to make sure the powers are the same. And since the powers are the same, then you can go ahead and start your problem. So since 3 is the same power as 3, we're going to combine our factors. 4.6 plus 8.72. And then you're just going to go times 10 to the third. Because that part doesn't change. You don't do plus, 10 to the third plus 10 to the third. You don't do that. Since the powers are the same, you're just going to use it once. So it's kind of like a common denominator. Since you have the same denominator in fractions, you just add the numerators. It's kind of like that. Okay, so you don't do anything when the power's the same. All right, here we go. So we're going to add these guys, and I'm going to use my calculator. 4.6 plus 8.72, and we get 13.32 times 10 to the third. Now, at this point right here, you might be thinking, okay, I'm done. I wrote my answer in scientific notation. But did you? Well, is C less than 10 greater than or equal to 1? And is this power an integer? We're good here. But this is not less than 10. So what you're going to have to do is you're going to write this in scientific notation, the proper way with the proper factor. So I'm going to move my decimal until I get to a number that's less than 10. If I only move it once, I'm now at 1.332. But since I move my decimal to the left, I now have to change my power. So I'm going to add 1 to my power. I'm going to talk about Lars here in a second. So we now have 1.332 times 10 to the fourth power. And at this point, you should be good. Just double check. Your factor's good and your powers are good. And you're done. So what can we do to help you guys out? Let me introduce to you Lars. Lars is a wonderful stick man with a face and a helping hand. He's there to help you remember this weird kind of process right now. And his name is Lars for a reason. Lars stands for something. So left, add, right, subtract. And yes, I will redo this so you guys can put in your composition book. So his name is there to help you on what you do. So if you have to move your decimal to the left, you're going to add however many times you move that decimal. If you have to move the decimal to the right, then you're going to subtract however many times you move the decimal to your powers. So when you add and subtract, that is to your powers. When you go left and right, that's how many times you move the decimal. And so Lars popped up right here. I'm just going to draw a quick little Lars face, helping hand. I don't care if you have the right number of fingers, but that's where Lars pops up. And he can pop up in one or two places, which is kind of cool. And I will redo this so you guys can see him and reiterate what Lars stands for. But every time we use Lars, we're going to write him down. And my Wi-Fi's been going a little weird, so I hopefully can get through all of these problems. All right, that's our first one. On the back side, we have, and this is just 1b, quantity 3.5 times 10 to the negative second minus the quantity 6.6 times 10 to the negative third. Right, he's getting all sloppy. So the first thing you have to ask yourself, are these powers the same? Hopefully you said no. Okay, so since they're not the same, what you have to do is you have to make them the same first. And what you're going to do is you're going to grab the smallest power. So you have to figure out which one is smaller, negative 2 or negative 3. Hopefully you said negative 3. So remember, guys, the smaller the power, when it comes to negatives, the farther it is from 0. So negative 3. So what we're going to do is we're going to change the smallest power into the larger power. We need to make them the same base 10 is what we're doing. So what we're going to do, I'm going to rewrite this under here, 6.6 times 10 to the negative 3. Now, what do you do to negative 3 to get to negative 2? Do you either add or subtract? You add. So, and we're going to figure out how many we do add. We're going to add just 1. Now, since we added, here it comes, we're going to move the decimal to the left. So I'm going to move the decimal to the left once. And I know this isn't in our seed factor, but that's okay. So we now have 0.66 times 10 to the negative second. We're going to subtract 3.5 times 10 to the negative 2. Whoops, negative 2. Now, since those guys now have the same power, now you can continue. And I'm sure some of you guys are asking, well, wait a minute, this factor doesn't fall in our range of less than 10, greater than or equal to 1. That's okay. It doesn't matter. When you have to change the powers, that's when you can do this. All right? Now, since they have the same power, now you're just going to follow the problem. So we have 3.5 minus 0.66. Be careful on where you line up your decimal. Add an extra 0 if you want. Times 10 to the negative second. All right. Don't forget to add a 0. Can't subtract, can't subtract. I was taught to go all the way over, so I'm going all the way over. 10 minus 6 is 4. What is this? 4 and 4, 8.2. So I have 2.84 times 10 to the negative second. At that point, ask yourself, is this in scientific notation? Does our factor of C fall in the range of less than 10, greater than or equal to 1? Yes, it does. Is this power good? Yes, it is. So we are good to go. So Lars pops up here. Now we got to draw Lars. And yes, I'm looking for him on your homework. My Lars has a ginormous hand and a really squished in face. But that's okay. All right. So that one's a little bit trickier because you have to make them the same power first. Let's do another one. We're going to do, I think, 2 more. So let's go 8.2, the quantity, times 10 to the second, plus the quantity 3.41 times 10 to the negative 1. And this is OYO number 1. First question, are they the same power? No, they're not. I went a little fast here. So which one do you change? Remember, you're going to change the smallest power into the largest power. So 2 and -1. Hopefully you said -1 is the smallest because any negative number is smaller than any positive number. All right, so now we're going to change this guy into the same base 10 as 10 to the second. So now you got to figure out what you do to -1 to get to -2. Do you add or subtract? You add. Okay, so -1, -1 to 0, 0 to 1, 0 to 2. So we're going to add 3. And we're going to now move the decimal 3 times. 1, 2, 3. Fill it in with zeros. So when I have 0.00341 times 10 to the second, because you now just changed that power, and now it's the same power as this guy, and we're good to go. And we're going to add that to 8.2 times 10 to the second. Now, since our powers are the same, we can go back to that problem. Nope, never mind. Yes, that is the same problem. Okay, go back to that problem, where you just combine them, your factors. So we have 8.2 plus 0.00341 times 10 to the second. So Lars popped up right here. Gotta draw Lars. There's a really kind of not great drawing of Lars, but I drew him because he helped us out here. Okay, now we're going to add these. So we're going to add a bunch of zeros. I can't see this. So 1, 4, 3. Yep, 0, 2.8. Times 10 to the second. And I'm going to rewrite that, guys. I'm having a hard time seeing. 8.20341 times 10 to the second. Okay, now I can see it better. At this point, is this number less than 10, greater than or equal to 1? Yes, it is. So a little trick you want to keep in mind. There only has to be one number to the left of the decimal for it to be in proper scientific notation range. But that number has to be greater than or the same as 1. And this guy is good to go. He's in scientific notation. So Lars helped us here change the powers to be the same. And our answer is already in scientific notation, so we do not need Lars again. Okay. So remember, however many you add to the power is however many times you move your decimal. There's a little bit to these. Okay, I'm going to do one more, and hopefully that'll help. And then if you guys need help, remember, just call me. Or, no, send me a message with your number, and I will call you. All right, quantity 7.8 times 10 to the -5 minus quantity. Keep forgetting to say quantity. 4.5 times 10 to the -5. And this is OYO2. All right. Here we go. First start out. Is the base, not the base, is the power the same? Yes, it is. So the good thing is we got this guy already down. So it's going to be something times 10 to the -5. And then we're going to combine our factors. So I have 7.8 minus 4.5. And of course, when we do this math, subtract, we have 3.3. So now we have 3.3 times 10 to the -5. And at that point, you're asking yourself, is that in scientific notation? Yes, it is. So, guys, we're done on this one. Did Lars even pop up to help you? No. So Lars can show up in two places. One, it can show up in making the powers the same. Not in this problem, but the last two problems. He can show up when you have to make your powers the same. And he can pop up, when you have to write your answer in scientific notation. Sometimes he pops up twice. Sometimes he doesn't even pop up, like this last problem we did. But that's okay. Doesn't matter. All right. Well, that's it for today. I want to try and keep that short. Tomorrow we'll be doing the same operation scientific notation, but we're going to be doing multiplication and division. So Lars helps you guys out for tomorrow as well. I just want to keep the problems separate. So on your homework tonight, you're going to see problems that you're going to do you're going to do problems from 10.7 twice. Okay, so make sure you keep those assignments separate. And I think that's it. So you guys have a wonderful day. No extra credit question today. Sorry, I'll think of one for tomorrow. Au revoir.